In this video, we will discuss traveling salesman problem. Before learning traveling salesman problem, let us discuss Hamiltonian circuit. We have defined Hamiltonian circuit as a Hamiltonian circuit in a connected graph G is defined as a closed walk that travels every vertex exactly once, except the starting vertex at which walk ends. This is nothing but Hamiltonian circuit. Thus, we have defined Hamiltonian circuit as a closed walk that travels every vertex exactly once except its end vertex. Now let us go to the traveling salesman problem. Traveling salesman problem is closely related with Hamiltonian circuit. This problem is stated as follows. A salesman is required to travel or to visit a number of cities during a trip given the distance between two cities in what order should he travel so as to visit every city once and return home with minimum mileage travel or with minimum distance travel. This is the traveling salesman problem. What is traveling salesman problem? This problem is stated as follows. A salesman is required to visit a number of cities during a trip. It is given that the distance between two cities and In what order should he travel so as to visit every city exactly once and return home with minimum distance traveled? This is the problem. To solve this problem by using graph theory, we represent the cities by vertices. By vertices and roads by edges. We will get a graph. In this graph, as distance between every two cities is given, every edge EI is associated with a real number, that is the distance between two cities, and this real number is called as weight of the edge. It is denoted by WEI. And such type of graph in which such type of graph in which weight of edge is given is called as weighted graph. WEI is the weight of each edge EI. In our problem, that is, in traveling salesman problem, if each of the city has road, to every other city, we have a complete weighted graph. Thus, in traveling salesman problem, if we draw the graph with cities as vertices and roads as edges, with weights given as a distance between the two cities to each edge, then we will get a complete graph. We will get a complete weighted graph. This graph has numerous Hamiltonian circuits. We are to pick the one which has the smallest sum of distances we know that the total number of Hamiltonian circuit in a complete graph with n vertices has can be shown to be n minus 1 factorial divided by 2. How this follows? This follows from the fact that starting from any one vertex we have n minus 1 edges to choose from the first vertex. Further, we have n minus 2 edges from second vertex. Similarly, n minus 3 edges from third vertex. And so on. As these being independent choices, we get n minus 1 factorial possible number of choices. This number is divided by 2 because each Hamiltonian circuit has been counted twice. Thus, the problem of traveling salesmen can always be solved by enumerating all n minus 1 factorial divided by 2 Hamiltonian circuits and calculating distance traveled in each Hamiltonian circuit. And then picking the shortest and then picking the shortest one. But for large number of vertices n or cities n, the labor involved is too great even for a digital computer. Therefore, the problem to solve the traveling salesman problem is to prescribe manageable algorithm a manageable algorithm for problems of arbitrary size. Has yet been to be found. This is the traveling salesman problem. In examination, the question may be asked, write short note on traveling salesman problem or explain the traveling salesman problem by using Hamiltonian circuits. Thank you.